force approach, the problem also tells you that n is could be as high as 45, and k, of course, could be whatever is the length of the 45th Fibonacci sequence. Now, if n is 45, it's not hard to imagine that the string can be very, very long.
Yes.
Right? So, brute force approach is going to drive you crazy, because trying to write down the string itself would take too long.
Yeah.
But it's a simple approach and it's going to work for you. Whether it works in any reasonable time is a different matter. The algorithm would be correct, and so you could set up a loop that generates all the 45 sequences, and whatever question I ask you, if I say give me the 12th character of the 30th Fibonacci sequence, well, you can go look it up and answer me. No big deal, right? And the only problem, of course, it's that it's not going to finish anytime this year or even in the next decade or whatever, right? So we have to come up with something smarter. That's what the problem is all about. And the brute force solution is of course a terrible solution. Okay, but it is a solution. All right, so where do we go from here? Now that we all understand what the challenges are, now that we understand where the difficulties are, what do we do? Yeah, Lazaro.
We can set it up so we don't have to recompute previous S of n's.
But still, if you're going to write it down, you're dead. Even if I have to write down just the nth sequence, it's going to be so long that it'll take me forever just to write it down. And then I have to go and look at the kth character. And what if I asked you for the last character? You're going to have to go to the 45th.
Yeah.
So I ask you for the last character in the 45th sequence. Well, forget about even the 44th. Just writing down the 45th sequence itself is going to be too long, and that's enough to blow your code.
Thinking it may have something to do with the fib value, so that number indicates a length, right? Since if I think fib 5 here,
Yeah.
it's made up of fib 4 and fib 3. So
Yeah.
depending on where that k lies, you could find the answer in either fib 3 or fib 4.
Right, but we're not dealing with numbers here. We're dealing with.
I mean, yeah, but I mean in terms of the substring.
Yeah.
Yeah.
Okay. So good. So you are on the right track. It turns out that the first thing you have to do is to find the parallel between the Fibonacci strings and the Fibonacci numbers, the Fibonacci sequence. So let me remind you what the Fibonacci sequence is, and let me remind you what the Fibonacci strings are. Now, what is the connection here?
It's the length of
They're both
Right?
the same, like there's no that the same like no length, there's no same length.
So the length of the first guy is that number.
Yeah.
Length of S of 1 is f of 1,
Yeah.
and so on and so forth. So the lengths reflect the Fibonacci sequence. And yeah.
When you look at the sequence, like when you look at F0, F1, both of them need after they're give me F2 equals 2. When I look at the string here, I was like, it's being the same with the string, which is AB was A plus B, or A times B equals to AB.
Yeah. Are you asking a question?
No, I'm just
You're thinking out loud.
I just look at the sequence like they both have similar weights. One's added, one's multiplying.
Yeah. Well, this is not multiply. This is a concatenation.
Yeah.
Don't confuse multiplication here.
So now we only have to go to where f of n is equal to 45? Or to...
Well, that's just to give you, by the way, the n equals 45 is to tell you, don't try to write this down. Okay, that's really what the message is. And then, now we have to find a shortcut.
Yeah, so which is, instead of going all the way to s of 45, or s of n, we can just stop as soon as we reach
Well,
the length of 45?
Let's talk about this. Can I list out all the Fibonacci sequence up to 45 quickly? Sorry?
Yes.
The answer is yes. Okay? So I can figure out the Fibonacci numbers, the Fibonacci sequence, but I cannot write down the Fibonacci string.
Oh, yeah.
Right? Because these numbers are going to get big, okay? But I cannot write down that sequence. And so what David was suggesting earlier is likely to work because of that. Yes, Alec.
So can we sequence to find the Fibonacci string?
Can we what?
Use the Fibonacci sequence to find the Fibonacci string.
In a way, that's what we're going to do.
Are the first two strings, are they going to be of length 1? Are they
Yeah.
guaranteed?
So that's what they've said, but I was going to keep that for the last slide and say, what if I had a more general Fibonacci sequence? That's not what the problem asks for, but yeah, let's solve this first, and then go to the general Fibonacci sequence. Yeah. All right. So I think you now have the rough idea in your head, right? This is now getting to be not so difficult. So the trick is that the length of the nth Fibonacci string is the Fibonacci number, is the nth Fibonacci number. So now that we know this, the cat is out of the bag. The only thing you need to know is that the nth Fibonacci number is as big as exponential in n. And that's something you need to know, because that means I cannot write down the string. And if you don't know that, you're going to be in trouble, because all hell breaks loose. Okay? All right, so now we are going to have to follow David's idea. Now, how do we use your idea and come up with a solution? Yeah.
Can we maybe map out, so if we have A and B, that's two different characters, is there a way to map it out in numbers?
A and B are two separate characters. So this is these are, A and B are not variables. They are real characters. Does that help you?
So,
Yeah.
okay, I know you said that the sequences would be too long, but instead of going to s of, let's say 45, right? Instead of going s to 45, let's say our k, the index we want to look at is 17. Can we now stop earlier to where we go like f of whatever is equal to 17, and then just use that index?
That doesn't help, because I don't even know if there is a nice pattern for the first 17 characters. Or what if I said 17 million and 433,396? If let's say that's my k,
Okay.
what are you going to do? It doesn't really help you. And what if k is the last character, whatever that length of the string is? Are you just going to go and do the whole thing? That again defeats your purpose.
Okay.
So forget about trying to write down the string. That's not going to work for you. It's only going to blow up in your face. So your goal is to figure out a different solution that uses this observation. This is the key observation. And the other observation that I should have written down here is that I can write down the Fibonacci numbers, the first 45 Fibonacci numbers, quickly, because that only takes me big O of 45. So I can do this. I'm just adding things, right? In each iteration, I'm just adding things, and I can quickly write those down. Yeah, what are you thinking?
No, I'm trying to see if there's a pattern. I think so far what I see is going A, B, B, A, B, B,
Yeah.
But
So you want to start from somewhere else.
So first we write all the Fibonacci numbers,
Yeah.
and then after we finish that, we can use the recursive formula for the string one. We check if it's on either f of I minus 2 or f of I minus 1. We keep going back until we get to the base case. It's either going to be s of 0 or s of 1.
Right.
That's
That's the general idea. So let's see if we can figure out some of the details. Sorry. Yeah. Right. So let's assume that we've figured out the Fibonacci numbers. Okay. So we've got the left side figured out. So we've written down all the 45 Fibonacci numbers, the first 45 Fibonacci numbers, and let's say here is the sequence, but I haven't written it down. Conceptually, let's just imagine that sequence. Okay, so we're asked the question, what is the kth character in this nth Fibonacci sequence? A Fibonacci string. We know it looks like that. What is more important is that we obtained the nth Fibonacci sequence in a very straightforward way. That was by concatenating the n minus 2th Fibonacci sequence with the n minus 1th Fibonacci sequence. And we know the length of this and we know the length of this because I have all my Fibonacci numbers. So therefore, all I have to do is to figure out whether, as Ricky pointed out, all I have to figure out is whether k falls in that green part or the blue part. How do I do that? I compare k with, yes?
With and
With
the Fibonacci number.
with the n minus 2th Fibonacci number. Right? Because we know that the length of this is the n minus 2th Fibonacci number. We know the length of this is the n minus 1th Fibonacci number. If k is less than this, well, this is exactly the n minus 2th sequence. So now I have reduced the problem to finding some character in the n minus 2th sequence.
Right.
On the other hand, if k is larger than, it'll be in the other one, but I have to be a little bit careful here because what is the recursive call going to be? Remember, it's just going to be a recursive program at this point, right? Is this all clear in your head?
Yeah.
Can you write this down? No problem? Yes?
I have somewhat a problem, but I think I know what.
You'd like to see the rest?
I think I know what you're talking about.
Okay. So I want to do find of n comma k. I first go and compute my Fibonacci numbers. I haven't written that down. So we just go and figure that out. We're going to check if k is less than the n minus 2th Fibonacci number. Right? If it is, then what's the recursive call? Yes? Find
well, you reduce n to n minus 2, and then k, it stays by itself.
K remains the same. So that's what it's going to look like. Clear? Because it's in the first half, it's somewhere in the n minus 2th Fibonacci string. So therefore, all I have to do is to find the kth character in the n minus 2th sequence. So now I've reduced the problem. And if it is not, what's that going to be? We know it's in the right half. And so, what's the recursive call?
Find n minus 1.
Find n minus 1, that's correct, comma,
Correct.
comma,
N minus 2.
comma.
You have to change the value at this point.
I have to
So
change the value. Why do I have to change the value?
Because now you're over n minus f of n minus 2, so you have to subtract that from f minus 2 from that.
That's right. So, let me give you the answer. This is what it should be. Now, I need you to explain to me why this is so. David just did, but I need you to explain this for yourself.
Come on. I think
So first of all, if k is less than Fibonacci number n minus 2, it's in the first half, so all I have to do is to figure out the right character in f of n minus 2. Sorry, s of n minus 2. Otherwise, I'm going to find some character in the right half, but since I'm looking for the kth position, and the first half is all n minus 2 Fibonacci string, I have to take off that length because now I'm searching in the right half, which is only the n minus 1th Fibonacci sequence. And so I'm only going to look for k minus the length of the n minus 2th Fibonacci sequence, which is over on the left. Is that clear? All right. So this is the heart of the program. This is your pretty much done. Now you have to kind of fill up all some of the details. What are the details? What am I missing here? So the first thing I have to do is to write down all my 45 Fibonacci numbers,
Yeah.
right? By the way, even if it's not 45, even if it's 4,000, well, I can do that because once I read n, I know what that n is, and I just have to compute all my n Fibonacci numbers. So let's say I do all my n Fibonacci numbers, and that's done somewhere at the top. Anything else I have to take care of?
Oh, we need a base case.
I need a base case because this is recursion. The
Yeah.
recursion has to bottom out. At some point it has to stop. If I don't make it stop, it'll just go forever, and that's never going to work. So what do I have to do? The base case is going to be what Ricky said earlier, which is, what is the base case? Nobody listened to you.
The first and second initial strings.
Right. So either n is equal to 1 or n is equal to 2. Sorry, n is equal to 0 or 1.
Oh, okay.
That will determine the answer.
And that would determine the answer. Yeah. I think I may have, I think that should be 0 and 1, not 1 and 2. Well, if n is equal to 1, then really it's something in that first string. Here, that first string is just of length 1, so I'm just going to report A. And if it's the second one, then I'll just return B. Good? Very, very simple. Now comes the next key part, which is convincing ourselves that this was efficient. What's the deal here? We know that the nth Fibonacci number is exponential in n. Right? That's what we said earlier. How much time are we taking for this?
Would it be log of n? Because you're kind of splitting it, like you're kind of, you're looking one side and the other side, and you're like splitting half.
Well, you are logging an exponential function.
Yeah.
Wouldn't it just be O of n? Because you're always just subtracting 1 or 2.
That's right. So this is a recursive program. So analyzing, looking at the time complexity requires a slightly different thinking. You don't see a for loop here, but the for loop is there because it's all in the recursion, right?
Yeah.
Okay, makes sense.
So you're starting with some value of n, and every time you make one recursive call, and that recursive call would decrease the value of n to either n minus 2 or n minus 1, which means it'll decrease it by 1 or 2. Let's assume it's the worst case. It always only reduces it by 1, which means I keep going until I bottom out, and I'll bottom out at 1 or 2. So therefore, I start at n, and in the worst case, I'll go to n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, and at the end, I'll stop. So it's an order n algorithm. What is missing here, though? What is missing here is the initial part where we had to compute the Fibonacci sequence. And how much time will that take me?
That'll take you within
You don't have to do it over.
One have to take you like an exponential time to do to loops, and
How much time will it take me? And why?
I would say exponential because due to loops and due to like multiple
You keep talking abstractly. You've got to get down to the
Okay.
So once again, let me show you the sequence. Yeah. So this is your sequence. Sorry.
Oh yeah, due to the adding, you had to add the calculations.
Yeah, which is?
One, two, 3. Which
Yeah.
is-
So how much time will it take me?
That will take you. That will take like. Would it be exponential or will it be linear? I'm just.
You're confused. So if I give you n and I ask you to find the nth Fibonacci number, I start at 1 and 1, and then I have to do additions n times. So that's order of n,
Or yes.
right?
Yeah.
So again, it's useful for you to think in terms of the. By the way, if you write a recursive program and say f of n equals f of n minus 1 plus f of n minus 2, that'll take you exponential time. So you are actually right, but that would be silly because it would be incredibly inefficient. So writing Fibonacci numbers, if I ask you to generate Fibonacci numbers, do not try to write a recursive program,
Okay.
right? Because if you did, it would go and recompute everything over and over and over and over again.
So you want to use memoization.
So that's why I use memoization, and essentially it's a kind of dynamic programming, right? Yeah.
Sorry, what is memoization?
Memoization is, it's not a typo, the R is not missing, it's a real word, is to make a memo, so put down something in memory. So in this case, we are remembering our previous computations. We started with the first two Fibonacci numbers. Then in order to compute the third one, I'm simply going to add the previous two, but I have to have it written down somewhere. I need to have it memoized. In order to find the eighth one, I need to add sixth and seventh, but unless I have it written down, I won't have it. And so that's what is meant by memoization. I put these down in memory in some form and then reuse them. And this happens quite a lot in the dynamic programming problems where we're going to solve subproblems and we're going to need the solutions to the subproblems over and over again at later point. And so that's what we have. Yeah.
And we have the entire sequence in memory, or just the
Yeah.
three?
Yeah, at least for the Fibonacci numbers, not for the Fibonacci strings. Sure. Yes.
So basically we just taking this, little Fibonacci, taking the little code that we have, taking the code that how this code works, and using it to solve our problems basically. So these are solving our problems like the Fibonacci strings, the Fibonacci sequence.
Right. Yeah. Any comments, questions here?
I actually learned a lot. Instead of thinking into like big N notation, I supposed to use more like
Yeah.
how the function works instead of how much time the function will take.
Yeah. So one thing that I would advise for you is that if you're having trouble conceptualizing what we just said, then it may be really beneficial for you to attend David's what did you call your class?
Like a beginner.
It's for
data
beginners,
structure.
yeah.
Yeah, we go over memoization.
So you'll see a lot of these concepts. When I ask you for a solution, for loop is not the right answer,
Okay.
because that just gives you a control structure. It tells you nothing about what it is that you want to solve.
Okay.
You need to be able to visualize the solution a little bit more, and if you're not, then David here can help you.
Although the memorization's a little more.
Yeah, I know. But memoization was not the question here. I'm just saying, more generally for Alec, it might be that that he needs to visualize solutions of easier problems before he starts to look at
Oh,
things
yeah,
like
yeah,
this.
yeah, 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 no problem with that.
Yeah.
When that starts?
September 8th, but if you want, I could kind of visualize this for you later.
Okay.
After this.
Thank you.
Mhm.
So what did we decide was the time complexity?
Oh, then.
O of n. Thank
Linear
you.
time.
So it's linear time. So even though the string is incredibly long, it only takes big O of n time to figure out an arbitrary character. So the way they've described the problem in the problem statement, it's quite nice. So what they say is that, all right, I know it's very hard to write down the nth Fibonacci sequence, but at least can I pick any character and figure that out? So that's what the problem is about. And unfortunately, that's all I have. I didn't have chance to prepare more. Is it's fine with you guys to stop here? Yeah.
Sorry, one more question. So you said, how would this change if we were to generalize it as a different number?
Yeah, that's good. Yeah, that's a good question. So I did mention that. What if your initial two strings are not A and B? Then after the recursion bottoms out, you have to actually do a little bit of work there. You have to go and look at that string and figure out what the kth character is.
Okay,
So
this
for the
actually-
base case, you'd have to write it separately.
Yeah.
Yeah. Other than that, nothing else changes. Yeah.
Okay, thank you.
Yeah, it would change the base case of the code that we wrote. So over here, we said if n is equal to 1, then return A. That'll change to, we'll call a little special function that says the base case for the first string and the base case for the second string. They will be separate modules, and you'll call them. But yeah, so it just shows how very easily and smoothly it generalizes without messing up the structure of the solution. And that structure of the solution needs to be in your head clearly, while these all become minor things to fix when you go to the general case. Okay. Yeah, so I was hoping, I wasn't sure what the audience was going to be like, so I took a more gentle problem. I'm happy to crank it up next time if you wish, and see that we do some more interesting stuff. Next week I'm going to be out of town, so it would have to be 2 weeks from today.
Yeah.
Okay.
Yeah.
That's good.
Okay. All right, guys.